Hello, this is John Greiner with Basin Safety Consulting and Training. This month is May 2020, and we're going to be covering hand and power tool safety. We're also going to be talking a little bit about what we experience on the well site itself. So we'll be looking at where we use specific tools, why we choose to use those tools, and what potentially can go wrong if we use the wrong tools. So the first thing we want to talk about is just what hand tools are. Obviously, most of us are familiar with these from a very young age, when our dad asked us to grab a flathead screwdriver and we came back with the Phillips, or vice versa. Very common mistake. So learning hand tools, what we call them, etc., is not necessarily the goal of this course, but rather to talk about the inherent hazards of using hand tools and when to opt for either powered tools or pneumatic tools, depending on the task that's at hand. Obviously, the main hazard of using hand tools is an injury to your hand, which is the most common injury in oil and gas, as well as across many industries. And also electrocution, believe it or not, is one of the most common hand injuries when working with tools. So depending on the type of tool, it's going to vary on the type of application. So the first thing I want to talk about is obviously using the right tool for the job. If you're not sure of what tool to use for a specific job, then you're probably not qualified to do that task. If it's a situation where truly the scenario requires a created tool or something that isn't readily available, then that may be an application. But typically 9 times out of 10, if there's a bolt, a screw, or a type of fitting that's required to meet a certain type of tool, and you're not sure, then maybe it's time to ask somebody else what type of tool to use and have them teach you how to do that job. So the reason I bring this picture up is this is just your average typical well site from Google Earth. So looking down at it, you have a tank battery on the top left. Then close to that you have your treaters. You have, it looks like, a gas processing unit there to the top right of the dike around the tank battery and the treaters. To the far right there on the top you have 2 flare stacks, and then you have the wellhead itself. And where the truck is parked, you have, or it looks like a truck actually, it appears to just be the dirt area. You have the freshwater shack, and then you have some piles around it. So inside of one of those treaters, you have a lot of different, this is a horizontal treater, you have a lot of different piping and equipment that's going to require different types of tools to take apart. So in looking at this, you can obviously see some valves in both the open and the closed position. You see some Kimrays, which are most of the red items there. Some of them are Kimray dumps, and some of them are Kimray gas meters. So with each of these different pieces of equipment, you may need multiple tools to take them apart. So I believe these are 3/8 inch bolts on the Kimrays, so that's going to be how you take that off. However, there's a little spring valve on the top of those that uses a different size of wrench. And then inside of it, if you're taking it apart, it even uses another size of wrench. Now, why Kimray decided to do that, you've got me, but knowing what tools are necessary to do a job prior to doing the job is the first step in choosing the right tool for the job. A lot of times we'll say, I need to take this apart or that apart. All right, and you'll go take a look at it and not necessarily get all the tools. You'll think about the first step, but not the second or the third step. And I'm guilty of that. We're all guilty of that. But looking inside of a treater, that's just the Kimray. But in many cases, to take things apart here, you're going to need a pipe wrench or a crescent wrench. And you may not just need one. So typically when you're taking a lot of this stuff off, you're going to need the pipe wrench itself, as well as another one to stabilize the other fittings so that they don't all turn in kind. So knowing what tools you need, making sure they're available, and understanding the job at hand is the first step in hand and power tool safety. Want to look at some other oil and gas specific units here. We have a wellhead, obviously. Looks like the polish rod has been is over to the left there, so we're not really looking at that, but we're looking at a stack here. It looks like that's a chemical treatment line there. And to take that apart, once again, you're going to need a variety of pipe wrenches and crescent wrenches. But before you do that work, obviously, both on the treater and here at the wellhead, you're going to want to make sure that anything that could go wrong when removing that equipment is isolated. So this kind of goes back to a few months ago when we went over lockout, tagout, knowing where your valves are and where to lock out, where to tag. And in this instance, and on the previous example inside the treater, there's a lot of different places you may need to lock or tag depending on where you're working and what you're doing. The next one is a flare stack. This is a Steffes flare stack. It's actually a pretty cool invention. This flare stack not only ignites the gas as it comes out automatically, versus just using a spark plug and a wire hooked up to a battery, which is very common on the older style flares. This one has a little igniter inside of it, and it also measures the gas as it comes out, so you can actually determine how much gas you're flaring, which until recently wasn't a big deal, but the state recently did try to tax oil and gas producers on how much gas they're flaring. Fortunately, they shut that down, because that would have been the nail in the coffin for a lot of operators out there as far as taxes go. But inside of this equipment, depending on the model of the flare, in this case it's a smart flare, so taking this apart, to fix it, there's a lot of electronics involved, therefore you need to have a different tool set than fixing a traditional flare. So not just what you're working on, but what model it is. And typically, some of this will be known inside the manufacturer's recommendation. If they have a book or a guidelines that you're supposed to follow. But you just consult those if they're available, and if not, then once again, ask somebody who's experienced. Okay, so getting into the basics of hand and power tool safety, obviously cuts, scrapes, hands getting pinched, amputations can happen, impaling and smashing. So I'm going to include saws and grinders in this as well. And in those cases especially, obviously I always want to wear eye protection, but sometimes gloves can create an additional hazard above and beyond what it is that you're working with. So not just the right tool for the job, but knowing what PPE to use or not use depending on what the work is. So as I mentioned earlier, the right tool for the job, we're all pretty familiar with this. Don't use a wrench as a hammer, for example, or a screwdriver as a pick. Knowing exactly what you need, making sure it's available. So that's the step number one, and number two, actually. And avoid slipping while using tools. This is kind of a no-brainer. I don't know anyone who's out there with a wrench thinking, I really want to slip this wrench while I'm using it and bust my knuckle against whatever it is that's around. No one's doing that intentionally. So saying it in this way is a little bit funny, but really to kind of bring this out and unpack it a little bit, avoiding slipping really results to planning the job accordingly and saying, hey, if I don't have a good bite on this, on this bolt while I'm unbolting it, what's another method to use this? Using a closed end wrench versus a crescent wrench, for example, knowing what you can do to prevent your hands from getting injured, even though a lot of us almost accept that as a risk. Yeah, I'm going to scrape my knuckles up, I'm going to scratch my hand up, it's just part of the job. Not necessarily. It doesn't have to be if you're using the right equipment. Then also holding the tool firmly, making sure you don't have any grease on your hands or on your gloves as you're using it, and the right PPE. And then, as I mentioned before, sometimes the right PPE can be no PPE. So inspecting tools is another big part of this. So knowing what can go wrong in that tool. For example, I'll go back to a crescent wrench. Obviously, we have our spindle there that closes and opens the wrench. Inspecting that for dust and debris that may be in there and have it seize up. Rust can also be, impact that from working properly. And there's ways to fix that. You can soak it in oil or, use PB Blaster, WD-40, etc. But, maintenance and inspection are a big part of hand tool safety. Cracks, rust, as I mentioned, loss of grip potentials. Like, hey, can I spray some liner on this to give it a little bit more grip? Would that enhance or prevent me from slipping? Any deformities in the tool? Because if they do break, especially if you have a lot of torque on them, pipe wrenches have swung around and hit people. Pieces of equipment have fallen apart or broken. Using cheaters, obviously in this instance, can break tools and harm tools. And then obviously, if you're using a power tool, looking for electrical cord nicks, abrasions, or if that insulation has broken through. When that happens, it can cause electric shock or electrocution. And as I mentioned before, planning the job is kind of the primary method of protecting yourself. So inspecting tools prior for leaving for the field, making sure you have all the tools in the truck that you need. This morning I was on a job out in Minot, North Dakota, and we were there doing actually some trench work, and the guys didn't have post hole pounders, they didn't have some lifting equipment that they needed, they didn't have pins for the trench box, and so we ended up having 2 or 3 hours of downtime, a lot of money, a lot of guys sitting around because they didn't plan the job properly. So always take a mental checklist or an actual checklist of what tools you're going to need for that day. And also, a good question I like to ask is if there's too many tools for a job. Now, depending on if you're carrying them on your horse and donkey or not, if you have a pickup truck with adequate room, you probably aren't going to have too many tools for the job. It's nice to have some extra on hand. I like to have, plenty of tools on hand, depending on what type of work. But I'm kind of a tool nut, so if I'm going to use a saw one time in my entire life, I'm probably going to buy that saw just so I have it. And some of you guys may be like that in the audience here. But also, finding tools, and I'm a big nut about this, finding tools that will make the job easier and more efficient rather than having to do it the quote old-fashioned way, or we can get it done, but we need 2 or 3 more people and all this stuff. Are there tools that make it safer and easier? These are good questions. Are not highly recommended on the job site. Hammers. Now, depending on the type of hammer and the quality of construction, if you buy those $2.99 tool sale at the gas station hammers, or really any tools, you're probably going to have some problems with them breaking down, cracking, falling apart, the head flying off when you're doing a job. So make sure that the quality of construction meets the type of task you're doing. If you're at the house hanging pictures with those little pin nails, you're probably fine with a $2 hammer. But if you're actually out there working, using them consistently, you want to make sure that it's of proper construction. If for some reason that does break, my grandpa taught me is, hey, all you got to do is pound a nail in the top and it'll spread that wood out and hold the head of the hammer on. Now, while that does work in a pinch, in our industry, that is not acceptable. We don't want to be modifying tools in a way that just kind of band-aids them to work for the next day, because once again, they're band-aids and eventually the problem will come back to bite you. So hammers, obviously, using something besides a hammer happens very often. Hammers are heavy. It's not the first tool you think of. So when something won't budge or move, sometimes we use other things as hammers. But, in fact, I saw today a guy he was pinning up the trench box once they finally got the pins, and was using another pin to do the job rather than a hammer. Took about 30 whacks at it. It moved maybe 1/4 of an inch, and then finally the guy hands him a hammer. 2 hits, the pin was in place. So saving time, saving money, saving energy, doing it safely can all be accomplished by using the right tool for the job. Also, using brass hammers in areas where sparking is an issue. They are not cheap, so if you have one, take extra special care of it. But essentially it's a soft metal that doesn't spark, and that's why you want to use one of those in any combustible atmosphere or hot work areas. And then also keeping your body out of the swing path of the hammer, and that goes, think about it at a 360-degree angle. Typically we think of elbow to shoulder fulcrum to hammer to item that we're hitting, but you also want to think under and behind that. You don't want it to swing around and hit you in the leg or in the back of the leg, or obviously somebody standing behind you. So making sure other people are clear of the area as well. So hand and power tool safety with pliers and wrenches. Once again, right tool for the job here is paramount. Very commonly incorrectly performed. So keeping hands clear of pinch points. Once again, as you're plying that, you want to make sure your knuckles aren't going to swing off. And if you have wrenches that have grip settings or lock settings, you want to make sure that you don't overdo it or underdo it. You can break these tools if you're not careful, if you overdo it. So making sure that they're properly sized, and even with your locking wrenches, making sure that it's designed for this. You don't want to have it on the smallest possible setting and just praying that it holds when you're doing your work. You want to make sure that it get a smaller wrench in that case rather than just barely getting by. You don't want to, especially with your monkey wrench here, you don't want to use it in a way that it's overextending itself. You want to use it in a way where the grip is proper and easy and relatively ergonomic. You don't want to be overextending your hand to use that tool either, because then you can get into all kinds of other issues with carpal tunnel and tearing nerves. And just remember, the nerves in your hand are not that strong, so taking care of those is also really important. So power tools are kind of another world. All power tools need to be double insulated. And on the power tool, you're going to see something that looks like a box with a little box inside of it. And that means that it's double insulated. Probably means it was made in America or out of an American manufacturing plant or design manufacturing plant. It's been UL listed, which is Uncle Louie. It's United Laboratories. It's been certified electronic. It's essentially meets all the standards required for work. So basically, what I'm trying to say, do not purchase your hand tools from China from Alibaba. All right, just make sure you get them from a qualified source, or the guy selling them out of a bucket down the road. Pawn shops, etc. Buy a qualified tool with a manufacturer's warranty. Some tools are sparking. Some are non-sparking, and those are called brushless or non-brushless. So depending on the atmosphere, again, you want to make sure you're using the right tool for the job. These also need to be inspected. We've got a saw there, making sure that the blade isn't cracked. And one way you do that is you can remove the blade and kind of hit it on a piece of metal while holding the very tip of it. If it rings, you're good to go. If you hear a thud, it means it's got a crack or a break in it. So it needs that metal continuity to work properly. If these become broken and you have a shrapnel situation, you yourself or other people around in the area can become seriously injured. Also making sure that if they have guards, that they're working properly, that you don't bypass the guard, remove the guard, etc. And then also, right tool for the right job. This is the reason that we have things such as impact drills. If a tool has two handles, making sure you're using two handles, it's designed for that purpose. Making sure that you're not overcompensating or just trying to get by with a smaller tool when you need a larger tool for that job. That includes drills, etc. So saws, as I mentioned before, checking the guarding on the saws, if checking the blade on the saws, making sure that they're appropriate and that they're working properly, that they're in place properly. You never want to leave them running when you're not there. That's a bad situation. And obviously never, cutting towards yourself in this instance. You should be on the right side of the saw where it's cutting away from yourself. And one thing about, saws, especially, your table saws, there are saws out there that have basically finger protection, and they can sense soft flesh or fingers. I think in the commercial they use hot dogs, but you can essentially, touch a hot dog to the blade and it may just barely nick it, but then it's going to shut the whole thing off. So there are engineering controls out there that have been around for a decade now that will prevent somebody from getting cut. So if you don't think you can do it safely, you probably can. You just may not have the information. My grandfather, and I may have said this in previous trainings, made his own table saw out of parts that he found around, the farm, and I think a belt from the engine of a car. I think he used the engine from a lawnmower or some other small engine to make his own table saw. Not appropriate, OSHA not approved, but worked for my grandpa. Unfortunately, he had all of his 10 fingers and toes. Grinders, this is an area that does not receive a lot of attention in our world. And, we'll walk by a grinder without a guard on it and just kind of like wink, like, yeah, no big deal, that's the way it is. But not having the guards on grinders, and a lot of times guys will tell me they cause a greater hazard than not, but then get an adjustable grinder guard. Get one that can be moved or utilized differently, or build a barrier. If you don't want to use the guard, fine, but make sure that there's a barrier between you and that tool so that no chips, debris, material, the blade itself can break off and harm you, as you see in this individual's picture. It's not just about the sparks, being worried about the sparks. It's about those blades. They're spinning at such a high velocity that if they break and if there's a perturbance that knocks it back towards you, it's going to sink into your flesh. Even if you have clothes on, even if you're wearing gloves, etc., it is going to cause some serious damage. So obviously the debris coming from them is an issue. You're going to get dust, so if you need a face mask or a shield, make sure that you have one in place, depending on what medium that you're working with. You want to make sure that you have a tight grip on the grinder at all times. If you can get a spark shield, not a bad idea. You want to make sure that the wheel is stopped before you set it down. You don't just want to turn it around so that it can keep spinning while you walk away. And then lastly, once again, same thing with the table saw or any saw with a blade. You can do a ring test to make sure that and that also works with your stone wheels here. You can take them off and you're going to hear that nice little ring with them. All right, so safe use. We've talked about a lot of different things. Making sure your hands are in the right place. You have the proper safety equipment on, including safety glasses. I'm having a struggle here and thinking of the word here. use use proper work platforms. Someone's going to think of the word if I don't before the end of the training and make fun of me for not thinking of it. But use proper work platforms. If you're working at heights, be extra careful when using two hands. If you're supposed to, if you need one to stabilize yourself, make sure that there's guardrails up, etc. A lot of electricians, and I know I cover this in the electric safety program. A lot of electricians die not from being electrocuted, but from being shocked, however mildly, and falling off of an elevated work platform, whether it be a ladder or scaffolding without the proper guardrail. So, know what you're working around and whether or not what you're doing can cause additional hazards outside of the work area that you're working with, which also includes lockout, tagout, etc. And JSAs, I'm trying to change the culture a little bit when it comes to a job safety analysis or job hazard analysis even. What I want individuals to start thinking about when they're doing a JSA is this is a job failure analysis. Worst case scenario, what can go wrong while I'm doing this job? Well, if I'm using a screwdriver as a hammer, what can go wrong? A, B, and C. Well, is that a risk that I'm willing to take? Because once you decide to take a certain risk, the consequences are a little bit out of your hands. If I tell my wife that she does not look good in said clothing, there's a consequence. Maybe I accept that consequence. Maybe I don't. But once I take the risk of the action, you can't take the words back. Once you take a risk with the work that you're doing, you can't take the consequences back. They're going to kind of play out as they're designed. Recently, I was on the phone with the OSHA director here in North Dakota, and we were discussing a pipeliner out there, and his theory was that if a trench collapses on one of his people, that it was that guy's time to go. And maybe the good Lord or whatever, the universe, decided that he doesn't need to be on the planet anymore. And that was his attitude towards properly shoring trenches. And that attitude of just, hey, you do what you do. If you get hurt, it's just a byproduct of the world. You can't do anything to stop it or change it. That's the wrong attitude. To me, that's a mentality of idiocy. Because if you spend the proper amount of time to assess the risk, determine what the natural consequences are of the different risks, and then choose appropriately, 99 out of 100 times, you're going to minimize your risk to the proper extent. So looking at the job and seeing what can fail, and not just saying, well, something can fail, and if it does fail, I'll deal with it then. But actually looking at it, using all your resources, eyes wide open, what can go wrong while doing this job, whether you're using hand tools, excavators, heavy equipment, torches, etc. What can go wrong while I'm doing this job? And then lastly, making sure you have the right tool for the job. And if not, it sucks, but spending the extra time, resources, and energy and money to get the right tool for the job. No one wants to admit that they forgot it. Sometimes we'll try to bypass or rig it to work for us. But in our world, if we want to be professional, we need to take accountability and make sure that we're using the right tool for the job so that we don't get ourselves hurt or other people hurt. Well, May's safety topic is a little bit short this month, so you're welcome. But this is a little bit shorter. We're just glad that you're out there working safely, and we're glad to be a part of your team. If you have any questions about the video or any pictures or anything you want to share with us, feel free to email me at jgreiner@basensafetyus.com. That's jgreiner@basensafetyus.com. Next month's topic will be a little bit different. You're going to be seeing me. We're actually going to be doing it live in our studio. We will have some videos and some other cool material that we're sharing with you guys. So looking forward to seeing you next month. Everybody have a great time, and good luck on the test.